Okay. Now today, we've been talking about the chemistry behind the radiation, radioactivity, behind the different types of radiation. We've been talking about nuclear power and how that works, and nuclear reactors. We've even talked about the accidents, which kind of brings us to this. What do we have to worry about with radiation? How scared are you? We live next to a nuclear power plant. Where, not many people do. There aren't that many in the world, a couple hundred, I think, only. And we live next to one. So how scared should we be about radiation? That's what I want to talk about today. All right? I want to talk about how it affects you, what it does to you, all right? What are the ways you can mitigate those effects, and what are the things that determine whether those effects are going to be bad or how bad they're going to be. All right? Well, first off, you should realize that radiation is something that you're exposed to all the time. Okay? You're being exposed to it right now. There's radiation in this room. Okay? It's coming from the sun. It's coming from the ground below you. It's coming from the pencil you're holding. It's coming from the water you're drinking. There's, believe it or not, radiation in all those things. All right? There's radiation in pretty much everything around you. Now, the question is, why am I not done? How am I still alive? Well, obviously, it's a question of several factors. How much radiation you're getting, how close to the source, how long are you being exposed, what type of radiation it is. Is it ionizing radiation? Is it really, there's different kinds of radiation. There's alpha, we saw that, beta, gamma radiation, right? There's all these different factors that are involved. And to say that radiation by itself, in and of itself, is bad is really false. You're constantly being exposed to radiation, and not all of it can be harming you, obviously. All right? But there is one way it does harm you. Radiation can damage DNA. Okay? There's no doubt about that. Ionizing radiation is powerful enough to damage DNA. And if it does that, there are two ways that can hurt you. Obviously, if you're exposed to a massive amount of radiation that damages enough of your cells, it will simply kill enough cells to kill you. All right? And that can happen. That's what happened at Hiroshima and Nagasaki. So many people died not just from the heat and the mechanical energy of the blast. That killed, obviously, a lot of people. But also from the gamma radiation that was given off. They were close enough. They got enough gamma radiation. They were just killed within, almost instantly or within days. They were dead because their burns were very much like if you were to look at somebody like a fire or a sun, if you were to go into fall into sleep under a sun lamp or that's what it would look like, blistering of the skin and that kind of stuff. And eventually you die because they just killed so many cells. But obviously a lot of people didn't die who were a little bit further away. What happened to them? Well, it can still harm you. All right? If you get radiation enough of it, and it damages the DNA, but that damaged DNA, well, if it just kills a couple of cells, no big deal. We have cells. We're killing. There, I just killed a few cells. Our skin cells on the outside, they're dead anyway, right? I'm killing cells all the time. All right. Well, how scared should I be? Well, the real damage isn't if you just kill a few cells, but if you damage the DNA and the cell doesn't die. What happens then? What do we call that? Cancer. Exactly. We call that cancer. If you damage the DNA and the cell continues to reproduce, but it's damaged so it can't do its job anymore. So now it's no longer a pancreas cell, or it's no longer a liver cell. It's no longer whatever. It's now decided I'm going to keep dividing and grow and grow and grow, but he's not doing his job he was supposed to be doing. We call that cancer. All right? And that's the other way it can hurt you. So aside from just killing the cell directly, it can damage the cell and have it be reproduced and contribute to possible cause of cancer. All right. The effect of this, however, has to do with a number of factors. All right. First one would be duration and even proximity to the source. I should probably list that in there as well. Duration and proximity. Type of radiation. Alpha radiation is less penetrating than beta, which is less than gamma. Okay? And what exactly was being exposed? What cells were being exposed at this time? Just dead skin cells? Brain cells? Reproductive cells? Which ones would be the most dangerous to expose them to? Radiation. We'll talk about that in a few minutes too. All right? Okay. Before I get to my next one's going to be biological sensitivity, which cells in your body are most susceptible. Before I get to that, let's just say a little bit about duration and proximity. All right, an analogy would be this. Look, radiation is a form of energy. It's a form of electromagnetic energy. It's at the far end of the spectrum, gamma radiation is in particular. And it's got a lot of energy to it. But like any form of radiation, it depends on how close you are to it and how long you're there. If I've got a flame, a candle flame, and I run my finger through that candle flame, it barely even hurts. I'm being exposed to that flame. If I leave my hand in that candle flame for a couple of seconds, it's going to hurt. And if I leave it in there for a couple of minutes, it's going to burn and destroy my hand. All right? Same thing's true for ionizing radiation. The closer you are to the source and the longer you're exposed to that, the more radiation, the more energy you're going to get from it. And therefore, the more damage it's going to do to your cells. All right? I want to talk, that's the obvious one. I want to talk about the type of radiation and the biological sensitivity. Let's start with the biological sensitivity first, okay? Now, you'll be able to tell me some stuff about this just with your knowledge of radiation. So I don't know anything about radiation. Actually, you do. Most of you, nowadays, most of us know somebody who's had cancer or has cancer right now. All right? We know that because we're living a lot longer nowadays. All right? 100 years ago, cancer was a death sentence, basically, so you wouldn't have had, there's a chance to know as many people with cancer because if they got cancer, they pretty much died very quickly. All right, now it's just not the case. The survival rate for most cancers is very high, and a lot of them, it's like 90% or more. All right, so we know people who've had it, and we know people who have been treated for it. So let's think about some of the things. What kind of cells, when they undergo radiation treatment, are being affected? Well, it turns out the ones that are affected the most are those cells, well, I just write that down first. Different cells are affected differently to radiation. Why do we expose cancer patients to radiation? What's the point of that, Emily?
To expose them to it so that they can, like, do whatever. I don't know. Go.
Good question.
Good answer.
Final answer, I don't know, is a good one. Does anybody know why I would expose the radiation or cancer patients to radiation? What's the point of that? Nobody really knows that? That's interesting.
I thought I did.
That's interesting. I had no idea. Ben?
To destroy the DNA even more so it stops reproducing.
Well, to destroy the cancer cells. Yeah. Because radiation is, like I said, I just told you a little while ago, it kills cells. And if I give it a high enough dose, it kills them outright. It kills pretty much any cell outright. All right? How you got your cancer could be from a number of factors. It doesn't have to be from radiation. It doesn't make any difference. But once that tumor is growing, once that cancer is growing, it can be killed by radiation. Problem. It can be killed by radiation, so can all the other cells around the tumor, right? So we have a problem with that. But the reason cancer cells are more susceptible to being killed by radiation is they are dividing very rapidly. That's why they're growing the tumor, okay? And it turns out that in general, the more division that's occurring in a cell, the more susceptible that cell is to radiation and will be harmed by it. Therefore, radiation will selectively hurt cancer cells more than most other cells because cancer cells, tumors are growing rapidly, especially tumors, fast-growing cancers in particular. All right? So that's one reason. That's the main reason why you're going to expose it to radiation. You're going to try to shrink or kill that tumor.
Is that what chemotherapy is?
No, chemotherapy is a little bit different. They often combine the two. Chemotherapy uses chemicals to try to selectively kill cancer cells as well. But radiation kills them in a different way, just directly by being exposed to the radiation. Now, here's where I said you guys would be able to tell me some stuff. You guys know people who have probably undergone this. What are some cells that will be very sensitive? And you would know this, that they're very sensitive, because you've probably seen the effects on people who've had cancer. What's the first thing you notice? Oh, yeah. Hair loss, absolutely. Hair loss. It's one of the first things you notice. Hair is extremely sensitive to radiation because it's one of the few things you can actually see growing in your body. I mean, you don't really notice a child if you go growing, from, you guys are probably even still growing, but you notice your hair growing. I mean, within a month you need to get a cut again. All right, so hair is one of the fastest things that's growing there. It's also very sensitive, therefore, to radiation. And guess what? People who have radiation lose their hair. All right? Yeah.
I'm going to go out on a limb and say your fingernails.
Everybody says fingernails next. The problem with fingernails is they are growing, obviously, but they're already what? Dead, yeah. So I really don't care about fingernails being exposed to radiation. They're already dead. You see, they're just a keratin or whatever. I forget what makes them up. They don't. Do you trim your eyelashes, Emily? Because I don't trim my eyelashes. Just saying. No, some other cells. Now these other ones will also make sense when we start talking about them based on your experience. White blood cells. People who have undergone radiation treatments have to worry about infections, don't they? They worry about infections because they are killing white blood cells, which are constantly being needed to fight infections. So you're making white blood cells in the lymph nodes and stuff. And so you're killing those with the radiation more selectively than you're killing other things. I'm going to have another list over here of the least sensitive things. Okay? What else? Reproductive cells. That's a biggie. We know this from anyone who's ever had an X-ray or a CAT scan or even just a dental X-ray. Guys in particular, what do they cover up on you guys when you have an X-ray?
Your lower half.
Yeah, your family jewels. They cover that up for a reason. Guys in particular are making lots and lots of reproductive cells, millions of sperm being made all the time. All right? Women, not so much have to worry about this. I mean, obviously, we don't want to be exposing women's ovaries to radiation either, but men certainly are much more susceptible. Women only basically have a certain number of eggs, right? And they throw one out every month from every other ovary. And that's about it. Men are making millions of sperm all the time, okay? And so men have to worry about this. If you get an X-ray, you basically, they always put that lead apron over you, especially over that part of you. It's kind of weird. You're probably thinking to yourself, well, what the heck? They're covering that. What about my head? They're not covering my head. There's a good reason for that. Over here on the least sensitive cells, guess what you're going to find? Nerve cells, brain tissue. That stuff isn't really dividing. So radiation doesn't really affect it very much. Fetal cells. Obviously, women, pregnant women, should not have X-rays or CAT scans. Shouldn't be exposed to this radiation. It's why it's very dangerous for pregnant women. If they are pregnant, they often will try to, if they have cancer as well, they would try to put off their treatments because they're obviously a baby, even a baby, not just inside the mother but outside, is growing very rapidly. So children should not be exposed. One of the things that we found for a different reason, Bo mentioned a little while ago about thyroid cancer, and especially in children after Chernobyl. You probably read about that in your thing. That wasn't necessarily due to the radiation, like gamma radiation, but rather due to one of the byproducts of fission is cesium, a radioactive isotope of cesium, which I believe mimics the, I think it's cesium, that mimics iodine. And your thyroid, incorporates iodine, so you would be concentrating radioactive particles of cesium in your thyroid. And that's why thyroid cancer cases did go up, increase a lot after Chernobyl in the immediate area around there. But in general, younger people, children, babies, fetus, all of these where you're growing very rapidly are going to be very susceptible to radiation. Skin cells. Now, it's funny. Skin's going to show up on both sides. We're constantly replacing skin cells, right? Because we're losing skin cells all the time. So you can get skin cancer, obviously. You can get skin cancer from going to the prom because half of you idiots who went to the prom went tanning first, right? Well, maybe not the guys, but the girls anyway. Tanning boots is just radiation. It's ultraviolet radiation that's going to come in and damage your skin cells. All right, so now you know. All right, but skin cells are going to show up over here too. I really don't care about the outer layer of skin cells because they're dead. It's the one where they're being produced in the dermis that I have to worry about them being affected. Okay, red blood cells. Again, if you know someone who's had radiation therapy from cancer, you'll probably know that they have to keep track of their red blood cell count. All right, and if it drops below a certain level, they often will have to even put off a treatment, all right, to another date, another month or whatever, because they have to bring that red blood cell count back up because it's killing. You're constantly producing red blood cells. I guess it's the spleen that produces them, I think. And so you're constantly producing these things, or your liver around them. Liver cells and toxins, I'm not sure. But either way, if you don't have enough, obviously it drops to a certain low level. You're going to have to put off the treatments because you can't afford to kill anymore. Intestinal cells, again, think of cancer patients. They often get sick to their stomach. They can't keep food down. You're destroying intestinal cells. All right. That's also, by the way, due to the chemicals they're using too. It's not just from radiation, but you are destroying intestinal cells, which are the lining, the inner lining is constantly being replaced there. And finally, of course, the biggie, cancer cells. All right. We want to kill the cancer cells. That's why we're exposing people to radiation in a hospital setting. And I want to show you something interesting about this. I'm just going to show you a little diagram here. Watch this. Okay. How do I manage? It's a very simple. It's one of these low-tech kind of solutions to a problem. All right. Let's say I've got a person who's, I'll stand them up. Here's a person. Okay. Here's his body. Here's his arms and legs. All right. Now let's say the tumor is inside right there. Okay. Now if I have to pass radiation through that tumor, I'm going to have to shoot it, with some source through that spot right there. Okay. And I'll shoot it through there. Well, the problem is it hits all these other good cells besides where the tumor is, right? And I'll be doing just as much damage to those cells here as I'm trying to do to the actual cancer cells. So you know what you do? You can shoot it that way, that way, that way, that way. You see what I'm doing there? If I rotate the source of shooting the gamma radiation or whatever radiation I'm using, and by the way, it's not always done this way. Sometimes it's done with implants. You can actually implant something that's radioactive next to the tumor. I mean, that works too. So it exposes the good healthy cells, because I don't want to kill these healthy cells. Now, what does that do? Remember I told you about duration? Now, these healthy cells out here away from the tumor did not get anywhere near the dose that this guy got because they all converged on that point. It's just kind of a low-tech solution to not exposing the rest of the body to as much radiation as I was exposing the tumor to. You see? And that works. By the way, there's other ways it works too. We can implant different radioactive things. You may have, someone with prostate cancer, for example, may have had that implanted. I know people who have had that as well. Okay. Now let's talk about the least sensitive ones. Least sensitive cells in your body would be stuff that's not dividing, like muscle cells. Muscle cells get bigger. You can grow your muscles by lifting, but you don't necessarily get any more muscles. Same thing's true with your nerve cells. And you guys are getting on my nerve cells. All right, so nerve cells, like your brain tissue, all right, not very sensitive to radiation, believe it or not. Skin cells. Why did I put skin cells here and here? Well, the outer layer of the skin cells are already dead. That's, we don't really have to worry about cells that are already dead. Same thing you're talking about. I don't know if anyone has ever had fingernail cancer. All right, I don't think fingernails can get cancer. All right, because they're already dead. And of course, any mature cells, which leaves you guys out, because you're not mature. Mature cells. So you're not very sensitive. As long as you stay immature, no chance of being affected by radiation, pretty much. Keep laughing at, reality TV, and you are safe. It's like an immune system from radiation. Thank you. Thank you. Finally Emily finally got that back there, by the way, so that's pretty good. All right. Okay. Now, let's talk about radiation and how far it can penetrate through different objects. And I want to talk about this. You already have these pictures. You do not need to draw them. You can just put down refer to pictures. Find this paper I gave you. Okay? Find that paper. It was probably about 3 or 4 days ago I gave you that paper. See how scared we should be of radiation. I'm going to put my gloves on. We're going to get a radioactive source. And we're going to get a little Geiger counter here. All right? This isn't technically a Geiger counter, but it's kind of like, it works like one. All right? It picks up radiation, and it makes a sound. So let's see if anybody's radioactive. Well, not seeing a whole lot here. Let's see what this. Anybody want some? I can put some muffins on this plate, and we could have some. Let's see. What?
Do you have any muffins?
Yeah, you want some? Anybody want this?
It's a stud finder.
It's not a stud finder. Doesn't do it with anything else. This is radioactive. It's very radioactive, actually. Here, listen to that.
Take your gloves off.
I could, but I don't want to.
No, do it.
You can handle this without you. I picked this up without my hands, without my gloves. Without my hands. I picked this up without my. I took my hands off. I picked this up. Am I scared?
No.
I'm not really scared, but I should say a few things about this. Okay. I can block this. Oh, I got some metal here. I think I got. You get that? There's a plate, Jackson, behind you. Metal plate. Pick that up. Way back there. You see a big plate of metal. See it? Big metal plate. Can't miss it. All right, bring it up here. Yeah. Yeah. Why don't you put that between here and there? See what happens.
Stop.
What? Yeah, go ahead. Yeah. Actually, come on this side so they can see better. So they don't think we're cheating here. I'm not cheating. There you go. Ow! All right, take it out. All right, good enough. Thank you. Now look at. So how worried should I be that I'm holding this thing right next to me? You know. Well, it turns out this stuff was sold in the 50s as something called Fiesta ware. You can still buy stuff that looks just like this. Go to Boscov's. I saw them. I saw the advertising. It's recently. It looks the same, but it's not the same. And it was the orange one that was the problem mostly. They used a uranium dye to make that orange color. All right? Yeah, real smart of them. And the thing is, not a whole lot of people are going to die from that. You shouldn't use them. And they have been. By the way, they're collector's items. These plates are worth money now. Not a lot, but they're worth some money because people do like to collect them. They're not that dangerous because they're mainly giving off alpha radiation. That's their number one source of radiation. If you look at your sheet here, alpha radiation is stopped by my skin. My hand will stop that radiation. Remember, if that radiation can't get to my cells that aren't dead, the outer layer of my skin being dead, okay, if it can't get there, then it can't do a whole lot of damage. Not to mention the fact that I don't sleep with this, I hope, next to, my gonads. All right? But the problem with this plate was you ate off of it. And if I were to scrape off some of that, glaze and color and get some of the uranium inside of me, then I got a problem because my intestinal cells are very sensitive to this. So that was dangerous. And they banned those. Of course, they stopped making those. Now they make them with non-uranium type dyes. But there's a lot of stuff they use uranium for. You know those glow-in-the-dark dials for clocks? You ever see those that kind of glow in the dark? Or really, almost a lot of the things that glow in the dark. They used to be made from a radioactive isotope. I think radium was one of the radioactive isotopes of radium. And once again, people worked at plants painting these dials. And one of the things they did, unfortunately, was what? They would try to get a better tip on their, and they would lick the tip of their paintbrush and be doing that too, which again caused problems. All right, we again are a little bit more knowledge about this stuff. Now we don't do that anymore. But I'm not really worried about being exposed to that. I mean, I wore gloves because you got cut in your hand. You don't really want to be exposed to it anymore. But I can hold that right next to my body. The shirt's going to block most of that radiation, and the skin's going to block the rest. Because alpha radiation doesn't have as much energy, doesn't have as much penetrating ability as the other guys do. Beta can make it through your hand, but a small piece of aluminum is going to stop it. Gamma radiation, that will go through a lot of stuff, but it can be stopped by lead. And by the way, in the sheet I'm going to give you, a packet I'm going to give you, neutrons it has as the most penetrating on this one, and the other one, gamma, has the most penetrating. Turns out, depends on what you use as your shield. Gamma radiation actually is blocked fairly well by these things here, okay, and neutrons can go through it. Neutrons are blocked very well by water, and gamma radiation can go through that better than neutrons can. So it depends. But both of these guys are much more penetrating than these two, so I worry about these. They also have a lot of energy. Gamma radiation has a ton of energy. Look where it is on that spectrum up there. All right, so they can do damage to your DNA. All right.
That's neutrons for you.
And neutrons also can cause mutations. They can be absorbed by different atoms, and then make that atom be radioactive.
You make a neutron gun.
So anyway, okay. So you have the type of radiation you're being exposed to, guys. Your biological sensitivity, Those are two factors. The duration, all of this is a factor. So, a lot of times when you looked up the stuff on these sheets, on Chernobyl, 3 Mile Island, and Fukushima, they gave you information. This one has it in, well, I don't even know what that is, but you saw them in Curies, REMS, RADs, all these different. I'm going to show you what those measurements mean in the next part of the class, but not today, not this part. I want to show you this first. All right, now I do have a little video clip here for you. It's just a couple, like not even 5 minutes long. All right, but it's turn that light off for me. Okay,
our countdown of myths, lies, and downright stupidity has reached number 6. Avoid all radiation.
What?
That's certainly the message we've been hearing from the media.
Everyone I touch is poisoned.
Hollywood films have long portrayed radiation as evil and powerful.
It'll all be over in a second.
It gives this man the power to kill anyone he touches. Fear of radiation was widespread even before the U.S. dropped bombs on Hiroshima and Nagasaki.
In Japan,
The blasts themselves killed more than 200,000 people, and many others died later from radiation exposure.
30% of the city's population was killed, some by radioactive gamma rays.
The New York Times wrote article after article about how radiation would change Japanese lives for centuries, that there would be genetic damage, defects for the next 1,000 years. But surprise, so far no such damage has appeared.
I want to pause just for a second. This isn't very long. As a matter of fact, we're not even watching the full amount of it because there's a second segment on this, I think. But let me just say something about this. Remember how I was kind of upset when they were saying stuff like on the 3 Mile Island one, we're going to make an area the size of Pennsylvania uninhabitable for, centuries or for millions of years or whatever. That's just so ridiculous to make that claim. I mean, it's not like you can make that claim with any degree of accuracy, knowing that we dropped bombs on these two places and people live in Hiroshima and Nagasaki to this day. Yes, we obviously kill a lot of people and we gave off a lot of radiation and contaminated the area. But there's a big difference between that. I mean, radiation's around you all the time anyway. All right? And what do you see? Some of the things you're going to find out about the survivors of this bomb blast. It's pretty interesting.
Yet we have grown up with the fears that radiation would cause all these deformed children.
Some researchers, like toxicology professor Ed Calabrese, now say blast survivors who were exposed to smaller amounts of radiation are living longer than normal. And in small doses, radiation may even be good for you.
How can any of it be good for you? It's all in the dose. What's going on at low doses is often seen to enhance immune performance and enhance longevity.
Researchers exposed these mice to small amounts of radiation and concluded it may have slowed their aging. The irradiated mice had more energy and shinier fur.
We find that at low doses, you can actually extend the lifespan of the mice.
What you're saying is that a little radiation works kind of like a vaccine to protect people?
That's true.
It's why in Europe, some people now bathe in radioactive water, saying it's good for them.
And this was a uranium mine.
And in Montana, some Americans spend time in these old mines where they breathe in radioactive gas.
There's got to be something to it because we both feel better when we leave here. We sleep better.
Now, many scientists say this is nonsense or dangerous, and it's yet to be proven that low-dose radiation is beneficial. But they do agree that the hysteria about radiation is hysteria.
Get everybody into safety areas and make sure that they...
I do want to pause it there to realize, look, I'm not saying that we should all go out and try to get as much radiation as possible. All right? It's not the same thing. There is a small minority of certain scientists, and some people call them pseudoscientists, who believe that small doses of radiation may actually be good for you. Kind of like, look, alcohol in high doses is toxic. You could actually die from drinking too much alcohol immediately. Like just from, if you drink enough alcohol, if you try to drink like 30 shots of alcohol and you weigh 110 pounds, you're going to die if you don't throw up first. And hopefully you'll throw up. Because alcohol is a poison. However, there's also, they're making the case that, well, kind of like red wine in a glass or two a day is supposed to be good for you. Is it possible that radiation in smaller doses is also good for you? Things that are toxic in large doses are not necessarily toxic, or even certainly not as toxic in small doses. And do we have to worry? But unfortunately, when they try to make those numbers for the Chernobyl one, 3.5 million, they were basically just taking the total amount of radiation that was given off and just linearly interpreting how that could possibly have killed this many people. And of course, they were totally and 100% wrong. The total number of people who died from radiation at Chernobyl was about 50 from the blast, maybe 2,000 to 4,000 since then in the past 30 years. All right, that's a big difference between 4,000 and 3.5 million, because you can't just do that. Small doses of radiation we are being exposed to right now, sitting here. Your radiation is going through your body from the ground and from the sun. You are breathing it in, and you're being exposed to radiation right now. If I turn that thing on, every now and then you're going to hear this guy click. All right? He doesn't click very often, but if I pointed at Maria, I'll probably click more often. There, you hear that? That's exactly what I said. Marie's radioactive. But there's radiation in this room right now that you're breathing. And the question is, how much is too much? When does it cause problems? Okay?
They stay there.
1979, the movie The China Syndrome set the stage for panic.
What is it?
An accident at Ventana.
Just weeks later, a nuclear power plant at 3 Mile Island, Pennsylvania released radioactivity into the air. People fled.
We're just going to go as far as Harrisburg for right now.
And many people thought the real bad news was being kept from them.
It's a lot worse than what they're telling us. Typical lies.
In truth, the people living in the area were exposed to an average of 6.5 millirems of radiation. We now know that's meaningless, given that every year all of us absorb about 30 from the ground, 26 from the sun, 10 from just one dental x-ray, 10 from food, 5 from our own drinking water.
The reason the general public is afraid of nuclear energy is because of the scare campaigns of groups like Greenpeace.
Patrick Moore co-founded Greenpeace. He says he's not surprised that people fear radiation.
It's because they are being told over and over and over again through the media that they are going to be damaged and killed by radiation from nuclear power.
Moore is now at odds with his former friends. He's now a consultant for the nuclear power industry.
Not a single person is being killed in the nuclear industry, and people are wanting to ban it. It's pure scare tactics.
But what about that accident at the Chernobyl nuclear power plant in the Ukraine? It terrified the world.
There are unconfirmed reports tonight that as many as 2,000 people have died.
The Washington Post headlined 30,000 deaths, 40,000. Worse than the A-bombs, they said. And how many people did die in Chernobyl?
I know it was in the tens of thousands. I don't know, 50 or 100,000.
On Earth Day this year, people told us that radiation
Killed thousands in Europe as a result of Chernobyl.
In truth, a study by 8 international agencies found 56 people were killed, mostly firefighters and workers at the plant. Thousands of other people may still die of cancer, but nowhere near the number that was predicted. The study says the biggest health menace the people of Chernobyl faced was psychological trauma, in part from fear. The fear was worse than the radiation. So next time someone scares you about radiation, remember that you're exposed to it all the time, without harm. And some people even want more of it.
Okay. All right. Turn that backlight on. I got one last thing I want to give you here today. Actually, 2 things. Let me pass these out for those people who are at home, though. I'm going to give you this packet here. I'll just go through it very quickly with you. And then I've got another little article here about the supposed beneficial effects of radiation. All right, now, again, I'm not endorsing that, but I do want you to see there is a difference between, we should not be as scared of radiation as we are.